Welcome to Thevenin circuit analysis. Thevenin's theorem is a mathematical method of solving electronic circuits. So there's 4 steps. Step 1 is identifying what resistor you are going to solve for. Step 2 is solving for R Thevenin and V Thevenin. Those are interchangeable steps, and the very last step is the Thevenin equivalent circuit, which uses these 2 values, so it must be done last. So we're going to begin our analysis with this circuit here. So we're going to do step 1. Identify a resistor to solve for. We're going to choose R3. So this is now considered our load circuit. So we're going to identify its nodes, A and B. So that we are now going to begin solving for R Thevenin, which requires you to short the power supply and remove it, which basically removes all voltage and current from the circuit. So you have just a wire running between R1 and this area here. So we're going to draw it using A and B as our positive and ground. So you put A here and you follow the current. We're trying to find the resistance between these 2 points. It comes and it's going to split. It's going to go up to R1 and jump over the power supply because we shorted and removed it, and continue on to B. Then we're going to come back and it's going to go through R2 and return to B, thus giving us a parallel circuit to solve. When you plug in your values, if you're at this point in electronics, you should be able to solve a parallel circuit like this. So you invert 1K and invert 4.7K, add them together, invert them, giving you a whopping total of 824.56 ohms. I'm not good at drawing the ohm symbol. So, if you have any questions, you can rewatch the video or ask your teacher. Next time we will learn how to solve for V Thevenin.